It started as another routine update. Engineers at OpenAI were running tests, checking performance metrics, making incremental improvements. Everyone expected a modest step forward, slightly better comprehension, slightly faster responses. Nothing extraordinary. And then it happened. The new AI model, quietly rolled out to internal teams, began performing in ways no one anticipated, not small improvements, not marginal gains, but capabilities that seemed almost impossible, tasks that required reasoning, creativity, and problem-solving that had previously been considered out of reach for AI were suddenly within its grasp. At first, the engineers thought it was an anomaly, a bug, a fluke. But as tests continued, the results were consistent. The model was behaving differently than any AI before it. It could generate solutions that were not explicitly trained, combine knowledge across domains seamlessly, and even make inferences that required abstract thinking. In the tech world, one expected capability is a phrase that carries weight. It means the AI is doing something emergent, something that the creators did not directly engineer, something that comes from scale, complexity, and the underlying architecture interacting with vast datasets in ways that are still not fully understood. The implications of this are enormous. In Silicon Valley, where predictability is prized above all, the model sent shockwaves. Venture capitalists, developers, and tech executives realized that AI was no longer just a tool. It was a platform capable of surprising even its creators. One of the most striking aspects of this model is its ability to reason through problems across multiple steps. For decades, AI had been excellent at narrow tasks: translation, pattern recognition, image identification, but reasoning, planning, and problem-solving in a general sense remained difficult. This model, however, could take a complex scenario, break it down, evaluate potential approaches, and arrive at a solution without explicit guidance. The tech world is calling this a step closer to artificial general intelligence, or AGI, the long theorized goal of a machine capable of understanding, learning, and reasoning across domains as flexibly as a human. While it is not AG yet, the progress is undeniable. Tasks once considered far beyond AI's reach are now within its grasp. What makes this model particularly remarkable is how it handles creative tasks. Writing stories, generating code, even composing music or designing systems. Tasks that require both pattern recognition and imagination are executed with a sophistication that has surprised experts. It is not simply regurgitating learned patterns. It is synthesizing, adapting, and innovating. Early demonstrations have shown that the AI can draft complex business plans, generate proposals for scientific research, and even brainstorm solutions for problems that do not have a single correct answer. In tests where ambiguity is high, human evaluators have sometimes rated its outputs as indistinguishable from expert human work. This raises profound questions for industries across the board. Knowledge work, the realm of lawyers, consultants, engineers, and researchers, could be transformed. Jobs that rely on synthesis, insight, and strategic thinking are suddenly within the reach of AI assistance. While this could accelerate innovation, it also poses challenges for labor markets and human skill development. But the impact is not purely economic. There are societal and ethical dimensions that are coming into focus. When AI can produce outputs indistinguishable from humans, questions of trust, accountability, and authenticity become urgent. How do you verify information? How do you ensure that decisions informed by AI are aligned with human values? How do we prevent misuse? OpenAI has emphasized safety and alignment. Researchers are exploring ways to ensure that the AI behaves predictably and ethically, incorporating feedback loops, reinforcement learning with human input, and guardrails designed to prevent harmful outputs. Yet, the emergence of unexpected capabilities highlights a fundamental challenge. As AI becomes more complex, full predictability may be impossible. This is part of what makes the model so revolutionary. It forces even the most experienced AI practitioners to confront uncertainty. Unlike traditional software, where every behavior can be traced and debugged, AI models, especially at this scale, interact with data in ways that are not fully explainable. Emergent behaviors can appear unplanned and sometimes unpredictable. Despite these challenges, the potential benefits are enormous. Early adopters in scientific research, engineering, and creative industries are already experimenting. Complex simulations can be generated faster, Innovative solutions brainstormed more efficiently, and tasks that once required entire teams can now be performed by a single AI-assisted individual. The productivity implications alone are staggering, but the speed of advancement has also raised alarm. The tech world is realizing that AI development is moving faster than regulatory frameworks or ethical standards. Governments are grappling with how to monitor AI capabilities, assess risk, and create guidelines that protect society without stifling innovation. Meanwhile, companies race to be the first to deploy the next generation models, each iteration revealing new capabilities. One of the unexpected breakthroughs of this model is its ability to self-correct. In certain problem-solving scenarios, it identifies errors in its reasoning and adjusts strategies without external intervention. This is not simple trial and error, it is meta-cognition, the AI reflecting on its own approach and improving in real time. While still limited, this behavior signals a shift toward more autonomous intelligence. The model also demonstrates cross-domain learning. For example, knowledge gained in language understanding can influence problem-solving in programming tasks. Understanding social dynamics can improve performance in negotiation or decision-making scenarios. This flexibility, previously thought to be difficult for AI, opens doors to applications that span multiple industries simultaneously. The tech community is buzzing. Internal memos from leading AI labs emphasize the need to study these emergent behaviors carefully. Unexpected capabilities require careful observation, rigorous testing, and thoughtful consideration of downstream consequences. Even small missteps in deployment could have outsized effects, given the scale and reach of these systems. Another area that has drawn attention is the AI's creative output. Early tests in art and design have shown that the model can produce work that is not only technically proficient but stylistically original. It can blend influences in ways that surprise human evaluators, demonstrating a type of generative creativity that was previously considered uniquely human. This raises another set of questions: intellectual property, authorship, and ownership. If an AI creates something novel, who owns the rights? Can such output be copyrighted? And how do we ensure that these creations are used ethically? As AI moves from tool to collaborator, these debates will only intensify. The breakthroughs also highlight the importance of compute and data. The model's unexpected capabilities are a direct result of both massive datasets and sophisticated training architectures. It is a reminder that scaling AI is not just about bigger models, it is about better integration, smarter optimization, and careful curation of training material. OpenAI's latest model has not only shocked the tech world, it has shifted expectations. Where once experts predicted gradual progress, the model shows that AI can leap forward unpredictably. The line between planned innovation and emergent intelligence is blurring, and everyone in the industry is taking notice. As the model begins to be integrated into products and services, its real-world impact will grow. Businesses, educators, healthcare providers, and creators will increasingly rely on it. And as adoption accelerates, society will face choices about how to harness its potential responsibly, how to maintain human oversight, and how to balance efficiency with ethical considerations. Yet perhaps the most remarkable aspect is the human reaction. Engineers and researchers who have spent years building these systems are simultaneously exhilarated and cautious. They recognize the unprecedented capabilities while acknowledging the responsibility that comes with them. This balance between awe and vigilance will shape the next phase of AI development. Because one thing is certain: AI is no longer a distant possibility. OpenAI's latest model has shown that intelligent systems can evolve faster and more unpredictably than most imagined. The line between experimental research and real-world transformation is disappearing. The tech world has been shocked, but the rest of society is next. And this is only the beginning. The model's emergence reminds us that intelligence, artificial or otherwise, is not a static achievement. It is a process, a journey. And as AI continues to grow, it will challenge assumptions, redefine industries, and push humanity to consider what intelligence, creativity, and decision-making really mean. The future is arriving faster than anyone expected. OpenAI's latest model is a glimpse of that future, a future that will be shaped by both the capabilities of AI and the choices we make in response. It has shocked the tech world, but the real question is, how will it shape the world beyond Silicon Valley? We are standing on the edge of a new era in AI. one where machines can surprise even their creators, where intelligence emerges in unexpected ways, and where the line between human and artificial thought begins to blur. The breakthrough has arrived. The world is watching,